Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 9. This is Section 11.1, Problem number 9. It says, fill in the charts provided to compute the limit of x plus 3 cubed minus 27 over x as x approaches 0. Now, ordinarily, when we take a limit, what we've seen in previous problems is, what we'd like to do first is just try to put in the value that the input is approaching, in this case 0. And the problem is the denominator zeroes out. So the next thing you'd like to do is try and factor and cancel. Now, that is possible with this one, but it's not that clear-cut. So if you can't factor, you can always resort to filling in a chart. This will always work, but it's very tedious. It's the most tedious, but it will work. So what the chart is doing is it's telling you for this function, put in input values that are getting ever closer to 0. So these are getting close to 0. These input values, negative 0.1, negative 0.01, negative 0.001. So these are values a tiny bit smaller than 0. And we're also going to put in values, input values, a little tiny bit bigger than 0, 0.1, 0.01, 0.001. And see what's happening with our output. What are we getting closer to? This is a good process to really understand how a limit works. So start by putting in a negative 0.1 for x. So we're going to have negative 0.1 plus 3 in parentheses to the third power. We're going to subtract 27. And there's an x in the denominator, and x is negative 0.1. Now, that's not the type of thing that any normal person is going to be able to do in their head. So I'll run it through the calculator. So in my parentheses, negative 0.1 plus 3, I can do that part as 2.9. You want to raise that to the third power, 2.9 times 2.9 times 2.9. I get an answer for that. I'm going to subtract 27 from my answer. Press equals. I get a number on the screen. It's negative 2.611. And I'm going to divide that answer by negative 0.1. And when I do, the two negatives cancel. And the result is 26.11. So if I were graphing this function, if I went over a negative 0.1 side to side, the graph would be up 26, a little more than 26. Let's try the next input. Let's put in an input of negative 0.01. So where I have an x, I'm going to put in a negative 0.01, do the math, and see what happens. So x plus 3 third power is going to be negative 0.01 plus 3 third power. Going to subtract 27. There's an x in the denominator, so in this box, the value for x is negative 0.01. And now I have to do that math and compute it. So in the parentheses, again, I can see negative 0.01 plus 3 is going to give me 2.99. I have to raise the 2.99 to the third power. So 2.99 times 2.99 times 2.99. I get an answer for that. I'm going to subtract 27 from my answer. Press equals. And I get an answer of negative 0.269101. And I'm going to divide that by negative 0.01. The negatives cancel. And the answer comes out to positive 26.9101. So when I put in a negative 0.01 for an x value, the output or y value I get is 26.9101. So now I'll go over to the next box, put in a negative 0.001 for x. So again, I'm putting in almost 0. So the parentheses on top, I'm going to do x plus 3 is negative 0.001 plus 3, because my x now is negative 0.001. That's going to be in parentheses, raised to the third power. I'm going to subtract 27. And there's an x in the denominator, and now x is 0.001. And then do the math again, which you really need to do with a calculator. In the parentheses, negative 0.001 plus 3, you can start with that. You're going to get in the parentheses 2.999. Now you're going to raise that 2.999 to the third power. Get an answer for that. I'm going to subtract 27 from that answer. And I get a lot of decimals, negative 0.026991001. I'm going to take the answer I got from the numerator, divide by negative 0.001. And the answer comes out to positive 26.991001. So if I put in a negative 0.001 for x, the answer I get out for y is 26.991001. So now let's fill in the bottom row. Let's put in input values or x values that are just a tiny bit larger than 0. So we want to put in stuff really, really close to 0 because that's what we're told to take the limit of as x approaches 0. So now the parentheses to the third power, x plus 3, becomes 0.1 plus 3. When we put in a 0.1 for x, that's in parentheses. It's going to be raised to the third power. We'll get an answer for that. When we do, we'll subtract 27 from that answer. And we're going to put an x in the denominator, so 0.1 in the denominator. And we'll do the math. Now, 0.1 plus 3, I can do that. Well, let's get it set with 3.1 in the parentheses to the third power. So again, 3.1 times 3.1 times 3.1. And I get 29.791. I'm going to subtract 27 from that. Get an answer 2.791. Divide that by 0.1. And the calculator tells me that the final answer is 27.91. So if I put in a 0.1 for x, I get out a 27.91 for y. The next box, put in a 0.01 for x. So again, my parentheses, I had x plus 3, so that x plus 3 becomes 0.01 plus 3. The parentheses are raised to the third power. I'm going to subtract 27. And I have an x in the denominator, a 0.01 in the denominator. Again, I'm filling in the function that's given. And now to do that math, in my parentheses, 0.01 plus 3 will be 3.01. I'm going to raise that to the third power. I get an answer. I'm going to subtract 27 from the answer I got, minus 27. Now I have an answer for the numerator, which is 0.270901. I'm going to divide that answer by 0.01. And the answer I get overall is 27.0901. So if I put in a positive 0.01 for x, I get out a positive 27.0901 for y. It seems we're getting closer to 27 as the output. We'll just fill in the final box. The final box, it says use for x 0.001 as an input value or x value. So in the parentheses, x plus 3 becomes 0.001 plus 3. Those parentheses are raised to the third power. You're going to subtract 27 from whatever you get as an answer. In the denominator, you have an x, which in this box, the value of x is going to be 0.001. And again, do the math. Of course, obviously, use your calculator. In the parentheses, 0.001 plus 3 will be 3.001. Raise that to the third power. I get an answer, a lot of decimals. I'm going to subtract 27 from my answer. And now, for the numerator overall, I get an answer with a lot of decimals, 0.027009001. Divide that by the 0.001 in the denominator, and the answer comes out to 27.009001. So after filling in all the boxes in this chart, it seems that the closer my input value gets to 0, the closer my output gets to 27. So you never actually get the 27 because you can never really put in a 0. But you can get as close to 27 as you like. You can keep putting in values for x that are closer and closer and closer to 0. I stopped at 0.001, but I could put in a decimal 7 or 8 zeros and a 1, and this answer would come out super close to 27. So as the input approaches 0, the output approaches 27.